So, today I'll be talking about dark energy. I've always loved astrophysics and it's what I want to do when I get older, so it was hard for me to settle on just one topic since there's so many cool things that I could talk about. Now, I'm not quite an astrophysicist yet, so there may be some simplified information, as the most fundamental and complicated levels are way beyond my current level of understanding. The history of dark energy starts with Einstein and his theory of general and special relativity. When he was developing his field equations, he found out that the way they worked out said that the universe had to be anything but static and unchanging in size. However, the current understanding at the time was that the universe was unchanging. So Einstein reworked his equations to include the cosmological constant, represented by lambda here, a coefficient that would regulate the changing of the universe. However, Einstein then found out that his original ideas were actually correct, and that the universe had to be anything but static. But the cosmological constant also proved useful in other ways, as you'll see. In the 90s, evidence was discovered that the universe was not only expanding, but its expansion was in fact accelerating. There are a few pieces of evidence for this, but one of the simplest to understand is one using something we've actually kind of learned this year. In astrophysics and cosmology, there's something called the cosmic microwave background. What this is kind of a heat map of the universe. Since the birth of the universe, many things have been emitting radiation in the form of light and other types of electromagnetic radiation. As we've learned a bit this year, as visible light gains a longer wavelength, it will start shifting into infrared light, then microwaves, then radio waves. The cosmic microwave background is the light that has been traveling through the universe since its birth, and has just now reached us. The reason that it's in microwaves is because all the waves with shorter wavelengths have been in space while that space has been expanding. Therefore, the space between each crest and trough also increases, redshifting the light into microwaves, which is some evidence of the universe's expansion. There are many theories about dark energy and inflation, but the easiest one to understand and for me to explain is the cosmological constant. This is one coefficient in Einstein field equations that describes the energy density of empty space itself, and it is also called vacuum energy. Most conventional things that we know, like matter and energy, have positive energy densities, which make gravity attractive and attract other things. However, the cosmological constant describes that space itself has a negative energy density, which means that space repels itself, expanding, and as it expands, more space appears, which means there is more negative energy density in that new space, which continues on and accelerates the expansion of space. This expansion means that everything in space is moving away from everything else. As there is no center of the universe, there is no center of the expansion. The easiest way to imagine this is if you had an infinite plane of rubber, and you started stretching it out. There would be no center of the expansion, however, every point on that plane would be moving away from everything else. I hope I taught this well, and that it's easy enough to understand.